Example 4 says finding the slope of a graph. Find the slopes of the graph of f of x equals x cubed at x equals -1, 0, and 1. Very, very similar to a problem that we did in the previous section, except in the previous section we had to use the limits. This was a much, much longer process using the limits. Let's see how easy it is now. Find the slopes of the graphs. That's just telling us all we need to do is find f prime of x, the derivative, at these given x values. X equals -1, 0, and 1. Find the slope of the graph is find the derivative, and then it gives us x values it wants us to plug in. Well, this is easy. If f of x is x cubed, it's a simple application of the power rule. F prime of x would then have to be drop the power, keep x, raise it to the power -1. That'd be 3x squared. So now all we need to do is evaluate it at the x values. So consider the x values. Again, we're plugging it into the derivative, which is 3x squared. The x values we care about are -1, 0, and 1. This one's not too bad to do by hand. If this were a more complicated function, this is where I'd use the table function in my calculator, where I would hit table, I'd clear it out, I'd put in 3x squared. I don't care what your start value is. I don't care what your step value is. You make sure you're on ask, and then you would just plug in -1, enter, 0, enter, 1, enter. Again, all those directions are in Canvas under the evaluating a table using the TI-30XS, and also in the limits section we just did that. Okay. So what would we have? Well, we'd have 3 times -1 squared. That would be 3. At 0, we'd have 3 times 0 squared, which would be 0. And 3 times 1 squared, which would be 3 as well. So what's the slope of the graph at those 3 points? When x equals -1, the answer is 3. When x equals 0, the answer is 0. And when x equals 1, the answer is 3. That's the slope of the line at those individual points. Just to give you an idea pictorially, what the heck did we just do? Look, I can follow the steps, I get there's a rule, I can plug in numbers, but what in the heck am I doing? I'm really big on understanding what you're doing, not just mimicking the instructor. So here's the graph of x cubed, looks something like this right here. I know it's not great, I don't really care about that. Here's the value when x equals -1. Here would be the point x equals -1. Consider that tangent line right there. We just determined that the slope of this line is 3. Look at x equals 0, that'd be this point right here. If you notice the tangent line, what's the slope of that tangent line? We just determined the slope of that tangent line is 0. Likewise, when we have x equals 1, here's that tangent line. And if you look at that tangent line, we just determined that the slope of that line, the slope of that line as well is 3. So that's what we did, is we found the slope of the graph at a point, or the slope of the tangent line, just simply using the power rule and plugging in numbers. We didn't have to find 2 points on the graph. We didn't have to move those 2 points infinitely closer. We didn't have to use any graphing technology whatsoever. We were able to use simple calculus and algebra to just find a derivative and plug in numbers. Very, very powerful tool. Let's learn some more rules. The next rule you're going to learn is called the constant multiple rule. So we know that the derivative of x is 1. We know that the derivative of x squared is 2x. The derivative of x cubed is 3x squared. But what happens if I throw a number in front there? For instance, what's the derivative of 5x? What's the derivative of 3x squared or 4x cubed? How do I handle that? That's what's called a constant multiple. And if you remember, it comes from the idea of the limit rules, where if you have a constant times a function, the limit of a constant times a function is the constant times the limit of the function. Well, we have the exact same rule because all a derivative is a limit. We have the corresponding rule. The derivative of a constant times a function is the constant times the derivative of the function. In other words, the derivative of 4x squared would be 4 times the derivative of x squared. which actually directly leads into our next problem, which is find the derivative of y equals 4x squared. So again, if we want to find the derivative of 4x squared, what we're going to do is find y prime would then be 4 times the derivative of x squared. Well, the derivative of x squared is 2x to the 1. Drop the power and then subtract 1 from the power. So 4 times 2 is 8, so this would be simplified to be simply 8x. Let's continue on. Look at b here. You have 5t cubed over 3. Well, what you really want to look at this is 5/3 times t squared. That's really just a constant multiple of 5/3. So when I want to find the derivative of f of t, that'd be f prime of t would be 5/3 times the derivative of t squared. The derivative of t squared would be 2t raised to the first. Again, drop the power and then subtract 1 from the exponent. Multiplying that out, what's 5/3 times 2? That would be 10/3 t, or you could write it as 10t over 3. Both of those are mathematically equivalent. I do not care which of those two you would do. I probably would have left it as 10/3 times t. Again, either acceptable answers. Let's continue on. Let's look at number C, or letter C. So y equals 7 over t. Again, this would be the same thing as 7 times, because it's in the bottom, we need to bring it to the top. T to the 1 is in the bottom, so it would be t to the negative 1 in the top. So if I wanted to find the derivative of this, y prime, that would be the constant, which would be 7, times the derivative of t to the negative 1. The derivative of t to the negative 1, drop the power, would be negative 1 t to the, well, negative 1 minus 1. Negative 1 minus 1 is negative 2. Again, be very careful. Please, please, please use your calculator on this one. Now we want to think about what is actually raised to that negative power. Only the t is raised to that negative power, so only the t has to go to the denominator. What's 7 times negative 1? Well, that would be negative 7 over t to the positive 2, or you could have written that as negative 7 over t squared. I don't care where the negative goes. It could go in the numerator, it could go out front, or it could go in the denominator. Those are all mathematically equivalent. All would have given you full credit. Let's go on to the next one, D. This is negative 5 over 2 times the square root of t. Well, I want to see this as negative 5 over 2 times t to the 1/2. The first thing I do with radicals is convert them to exponential form. And then I need to go even a little further because I need to bring that t to the numerator. So really, and this is a stretch, make sure you understand this, the fraction would be negative 5/2. That's the constant multiple, negative 5/2. And then I would have t to the negative 1/2, because when I bring it to the numerator, that exponent has to become negative. So that's what I'm going to be finding the derivative of. So when I find the derivative of that, y prime, that constant multiple is negative 5/2, so that negative 5/2 is going to be out in front. Now I'm going to find the derivative of t to the negative 1/2. I drop the power, that would be negative 1/2 t. Well, that would be raised to the negative 1/2 minus 1. I want you to be extremely careful with that. What's negative 1/2 minus 1? Negative 1/2 minus 1 is negative 3/2. I have a lot to do here. I have a lot to be careful with. What I have to do is multiply negative 5/2 times negative 1/2. Negative 5/2 times negative 1/2 would be a positive 5/4. Then I also have the t to the negative 3/2. That negative 3/2, I need to throw it into the denominator and make that exponent positive. So what would I actually have? Here I'd have well, we said it was positive 5/4, so that would be 5 over 4. But then I need to move that t to the 3/2 into the denominator. So it'd be t to the 3/2 in the denominator. But then one last thing I need to look at is I started in radical form, and anytime you start in radical form, you need to end in radical form. Remember, the numerator is the exponent, the denominator is the radical. In this case, the exponent would be a 3, and the radical would be a square root. So this would be 5 over 4 times the square root of t cubed. Be very careful with that. 5 over 4 times the square root of t cubed. Again, I told you I'd step back multiple times. I wanted to ask you, is calculus difficult? And hopefully you get the answer is no, because the only calculus we used is between this step where we had negative 5/2 t to the negative 1/2, In this step where we had negative 5/2, and then all we did was drop the power and subtract 1. That is the only calculus involved in this problem, dropping the power and subtracting 1 from the power. Every single other step, make sure you know your exponential rules and converting radicals to exponents. Every other step is just algebra.